Yeah. Yeah, go quick. I'll have to. Yeah, I'll just go quick. They pull you over, tell them you're just running late.
Are you recording?
Yes. Okay. So, this is a day that some of you, I'm sure, have been looking forward to.
Oh my God! Is it Uranus?
I've just finished the moons of Saturn, so we are going to turn on the jet boosters and we are going to head to the next of the outer planets. Welcome, everybody, to the amazing world of Uranus, the cold planet.
When you bring out the handout, yeah.
Okay.
Anyway, so basically,
Oh.
yeah.
So,
That's what happened.
Uranus is the cold planet. A little bit about, well, go ahead and I apologize for the picture. It's like they just have something against wearing clothing, and they just roll out of bed with their bedsheet or something. Yeah, I know, right?
He's drinking a cool
Yeah. He's doing like a
He's covering more of his skin with his beard than with his clothing. Go ahead and write down the first 3 bullet points. First 3 bullet points. So,
I already have one.
oh, thanks. A little bit about Uranus here. So, first off, the pronunciation. You can hear it one of 2 ways. Some people say Uranus, some people say Uranus. In terms of the mythological word that's derived from the Roman god, the proper pronunciation is Uranus. The more modern scientists and everybody that says Uranus, that saying mostly came in because of the embarrassment of saying Uranus. So the actual pronunciation is Uranus. If you Google how to pronounce it, it'll pop right up with how to pronounce it, and it is Uranus. So that's how I'm going to call it. Good luck today. As far as the surface of Uranus goes, it is an ice giant, and there is no solid surface on Uranus. And just like the other gas planets, under the clouds, the atmospheric pressure is going to rise and rise, and as it does so, that gas, which would be the clouds, eventually morphs into a liquid. And we're going to define the surface of Uranus as the spot where the pressure is roughly equivalent to the pressure on the surface of the Earth. Of course, Uranus is blue. You can see from this picture here, we've got the cloud tops, and this just represents a probe that a prior mission sent into Uranus. You can see clouds on Uranus are made of methane. Go ahead and put down this first bullet point. Nothing yet. I'll let you know what you need to write down. If I don't say anything, just assume you don't need it.
We're supposed to write down that whole slide?
Just the first bullet point here.
Clint, shut up. Mm-hmm.
What'd he say?
She needs a dick. Oh my god. You need leggings. You most definitely need that. You know what you need to do? Stop talking to me. Okay, stop talking.
So the fact that the clouds on Uranus are made of methane is important. It plays a part into why Uranus looks the way it does. So why is Uranus blue? The reason is because it receives white light from the sun. The sun is giving off white light, which contains every color of the spectrum. That's what white light is. And the methane that Uranus has takes that white light and it absorbs, it brings in the red light. So you're just left with the bluish colors to reflect back into our eyes. So that's why the blue light is, that's why we see blue light. It's the only color that's reflected back into space. From this slide, go ahead and write down the second bullet point. You also might want to write down that that's why it looks blue. In terms of the atmosphere on the surface of Uranus, you would sink down into its surface just like you would with Jupiter, just like you would with Saturn. And it's mostly made up of hydrogen, also contains things like ammonia and methane. Ammonia is mostly present in the cloud tops, just like it is with Jupiter. So it has a lot of similarities to those other planets. Voyager 2 was the first and only time we actually have an up-close look at Uranus. It looked like a dead planet when the Voyager 2 went by. It looked just like this. It was just a blue ball. So no real features were present as it went by. There's a picture of Voyager. This is just an artistic representation of what that spacecraft looked like. But it was kind of interesting. Later on, that changed. In the 1990s, you could actually notice that there are cloud bands, and you could even see that there's this dark spot on Uranus. So we've got this band right here of clouds, and when you look real close, you can see that dark spot right there. And you can actually zoom in on that. Zoomed in picture of the dark spot on Uranus. So yeah, as I mentioned, its atmosphere changes over time. In the 1980s, when it was first seen, it was colorless. It just looked like it was a blue blob out there. But you can see as time goes on, and these were pictures taken by the Hubble telescope, you can see different activity kind of coming and going. 2007, it's kind of back to that blue ball that we saw before with no real features on it. Does a little bit. Uranus is rather windy. Not quite as windy as Saturn, though. Most of the wind occurs halfway between the poles and the equator. And if you were talking about this position on Earth, it would be about where we are. We're roughly halfway between the equator and the pole. We're 40-something latitude. So in our location, if this was Uranus, we would be experiencing a lot of winds right here.
Nice one.
The atmosphere on Uranus is rather thick, and it's bent over. Uranus rotates on its side. This is one of the big features about this planet. It does not rotate like this, like all the other planets. It rotates like that, which is completely different from everything. And the rings that go around Uranus are the exact same. They go around it vertically. And maybe all the other planets are the ones that are tipped to the side. So from this slide, I'd like you to write down that they're very faint and that they're mostly made up of debris 1 foot to 60 feet across. It is big. It's enormous. The first 2 bullet points. Label them rings of Uranus, of course. First and second. So the thing to kind of notice about this slide is when we compare, and this is the important part of this slide if I were to pick something out, if we were to compare the size of the material, listen up folks, if we were to compare the size of the material that makes up the rings of Saturn and compare that with the size of the material that makes up the rings of Uranus, this material is much, much larger. The rings on Saturn are made up of much more fine, mostly dusty material. But when you go to Uranus, it's at least 1 foot long, sometimes 60 feet in length, is the material that makes up these rings. In terms of size, Uranus is 4 times as large as Earth. So if you have Uranus sitting here, you've got 4 Earths that would go straight across, 31,800 miles. So it's rather large. And in terms of volume, you could actually jam 63 Earths into Uranus. You want to write this down.
What are the gaps in the rings on Uranus called?
I don't know if they have a name. So again, when we're talking about volume, we're talking about if we ground up the Earth and we let it fall into Uranus, you could fit 63 of those. You could not fix 63 actual marbles of Earth in there. It's as though you grind it up and just let it drop in. So average density, 1.32 grams per centimeter cubed. This is more than Saturn, and it is more than 1. So Uranus does not float like Saturn does. Some spatial measurements here. These are just sort of for reference. It's the 7th planet from the Sun. It is roughly 20 Earth to Sun distances away, and its orbital speed is at 4.23 miles per hour, much less than a place like Mercury or Venus that were in the range of 19 or 30 miles per second. So it's still going pretty quick, but comparatively not so much. You can write both of these down. So, even though Uranus spins around once in 17 hours, that is not how long a day would be on Uranus. Because if Uranus is spinning like this, and the sun is, right here, one day is going to last and last and last until you get halfway around the sun. So one day lasts for about 42 years. I'll have you put that in your notes later. But again, if the sun is where you guys are, and it's spinning like this, it doesn't matter if it goes around once. That doesn't mean the sun is going to rise or set. For you, it would look like it's going around in a little circle above your head. So each day on Uranus lasts a long, long, long time. That also has a big impact on the seasons here, too. The seasons are 42 years each. So that'd be kind of rough. Temperature at 1.1 bar. These are the cloud tops here. Negative 371. I'm going to let you skip over this. Who is this? Who can tell me? There we go. From Mortal Kombat.
Oh, I thought that was Scorpion.
I always thought
No, I'm just playing.
that this version of Sub-Zero looked like Shredder.
Yeah, he did.
Yeah. So, of course, if we're going to descend to the temperature at 1 bar, the spot where it's the same pressure as Earth, it's going to be warmer. But as I mentioned before, now that we're getting further and further away from the sun, this temperature is getting less and less different. It is a little bit warmer, negative 323, but it's still very, very cold. Now, like Earth and like Saturn and like Jupiter, Uranus has a magnetic field, and this is primarily what your handout deals with. You can see the little lines here. These are the magnetic field lines on Uranus, and it's kind of interesting. If you were to actually take and, if you're on Earth, you could pretty much represent our magnetic field as though you take Earth and you put a straight up and down magnet right in the middle. That's a pretty accurate way to describe Earth's magnetic field and how it behaves. But for Uranus, it's much different. The magnetic field here would be represented by a magnet that is very, very off-kilter. It does not go through the exact middle of the planet. So the alignment of the magnetic field on Uranus is rather strange, and we're not quite sure exactly what's producing it, and we're not quite sure exactly why it's angled that way. But one thing that we do want to take note of is that it is generated at shallow depths within the planet's water ammonia ocean. So this is on your handout. Put a little arrow next to this. Middle bullet point. So it's kind of interesting when we try and figure out why its magnetic field is actually there and why it's angled so strangely, and that's something for future studies. It's also kind of fascinating because one of the other side effects, well, remember how Jupiter had a magnetic field that could be felt all the way back to Saturn, and it could be felt that far back because of the solar wind. The sun's solar wind would push it back that way really, really far. Well, one of the effects that Uranus's orientation has on magnetic fields is it causes it to kind of go backwards in a corkscrew fashion because it's spinning. And so this is what the magnetic field of Uranus looks like from a side view. It goes backwards, and it kind of goes, together, and it comes out and goes together. And that's because of the way that Uranus is tilted like this and the way it's rotating. Kind of a strange thing to see. Another question might be, is there water or ice on Uranus? And there is some water vapor that does exist on the planet. The most important part from this slide, and what you should write down, is that as you descend deeper and deeper into Uranus, the ratio of water to hydrogen is going to go up as we descend. So, as you go further and further inside, you're going to find more and more water, less and less hydrogen. So you're going to want to write down that last bullet point. So this is a pretty common theme with these outer planets. Hydrogen is the most common element in these worlds, and as you go deeper and deeper inside of them, things get more and more wet, things get more and more watery, and Uranus is no exception. You start out on the clouds where there's a lot of hydrogen, but the deeper you go, the more water you're going to find in there, and that's due to the pressures. In terms of composition, Uranus has gaseous hydrogen on the outside. Things turn more liquidy on the inside, as I just mentioned, and it does have a solid core of iron and rock there. In terms of gravity, it's not too different from the Earth, and actually you would feel lighter on Uranus than you would on Earth. Even though Uranus is so much bigger than the Earth, you're going to feel lighter there because Uranus isn't very dense. It is extremely sparse. All those molecules are really spread out. And so gravity is a function of how much material, how many atoms are there. There's actually less atoms on Uranus than there are on Earth. Earth is just much more compact, and that's why it's smaller. So on that same note, you'd be able to jump a little bit higher than on Earth. In terms of the sun, though, now the sun is getting real small. Now make no mistake, it's still very bright when you're at Uranus. But compared to Earth, it is much smaller. It would still hurt your eyes to stare at it, but it is getting very small. You can only see Uranus at nighttime. You cannot see Uranus during the day, and the reason for that is because it is just too dim. However, Uranus is an important place because it is the very last planet that we can actually see without the aid of a telescope or binoculars. Go ahead and write down this bullet point right here. Just barely bright enough to be seen when conditions are best. So in terms of knowing what you're looking at, there's really no way to tell if what you see is Uranus. And the reason for that is because all it's going to look like is a super faint star. If stargazing conditions are best, like you're 50 miles away from Milwaukee, you're away from all big cities and all light pollution, and it's a perfectly clear sky, under those best conditions, you'll just be able to barely see it as an extremely faint blue star. But again, unless you know exactly where it is with respect to some other stars, there's no way you're going to know that that's what you're seeing up there. If you have a decent telescope like mine in the back, this is the sort of thing you'll see. It'll look like a small bright disk. You're definitely not going to be able to see the features unless you have a much larger telescope, and you're certainly not going to be able to see the rings. The sky on Uranus is pretty cool. It's going to be light blue, cyan, if you know your colors. That's like one of those colors you'd see in the big 64 pack of crayons.
Biggest flex back in the day.
You don't have to write it down, but this is kind of a neat picture. What do you suppose is going to happen when we have our sacrificial freshmen jump out of the spacecraft on Uranus? What will be their fate? Disintegration?
They'll turn into ice cube.
You guys are exactly correct. They would turn into an ice cube, followed closely by disintegration.
Wait, really?
Yep. You nailed that one. Go ahead and write this down. Just do it without a spacesuit. So even with a really good spacesuit, you're not going to want to spend any time inside Uranus for a lot of reasons. In terms of why this planet looks young and kind of goes against the nebular hypothesis of how our solar system formed, go ahead and write this down. So just to elaborate on this a little bit further, the reason that Uranus basically disproves the naturalistic idea of how our solar system formed is simply because it spins on its side. And the whole idea behind the nebular hypothesis is that you have this big gas cloud that condenses into planets, and they all kind of spin the same way. And so not only does Venus ruin this whole idea by spinning the wrong way, but Uranus ruins the idea because it's spinning the wrong way too, but in a different way. Uranus is spinning on its side. And so one of the ways that they try and fix this is they say maybe Uranus was hit by a big asteroid and it knocked it on its side, but you would expect a very big effect on Uranus's orbit as it goes around the sun on that. It should not be going around in a perfectly circular plane like the rest of the planets are, and it shows no evidence of that. A couple other fun facts about Uranus. It is colder than Neptune. First planet to be discovered with a telescope. And I bet you guys didn't know this, but some people actually think that if you go super deep into Uranus, there's actually diamonds in there. So in terms of what you should write down on this slide, do the fourth bullet point. Summer and winter last one long day, which is 42 years. Because again, the same part of the planet is facing the sun for that same period of time.
The fourth one?
Yep, the fourth one. Right here. Summer and winter last one long day, 42 years.
So,
Kind of surprised. You guys really kept it together good for this one. I have some classes where it's like every slide, it's like explosion of laughter. I'm cool either way, so whatever. You got to embrace it. If I didn't want to embrace it, I would have gone to the lame pronunciation of Uranus. So, it is colder than Neptune. The next planet we're going to look at is Neptune. And even though Neptune's further away, it's actually warmer than Uranus. That's why I called Uranus the cold planet. But a couple other things before we wrap up today. It was only visited once in 1986. It has not been filmed or taken pictures of close-up since that time. Uranus, unfortunately, does not get first place for anything. But it does come in second place for a couple things, and you'll want to write all these down. Well, it's the second coldest planet. What's the question?
how is it labeled the cold planet if it's not the coldest?
I labeled it the cold planet because, surprisingly, it is colder than the next planet out. Yep. Who gets first place for sportsmanship, do you think?
Pluto.
Pluto does.
I think it's first place for cold.
It's always been one, too. Definitely.
Yep. Yeah, Pluto racks up the awards here. Once we get to it. Now, let me quick end the video. A couple announcements.